I did a video on AWS Backup last week, and I did a small demonstration on how to use AWS Backup to backup data from a DynamoDB table and an RDS instance, and how to use cross-account backup strategies across two accounts for a more resilient architecture. I did that demonstration with Terraform code that I had written maybe a year or two ago, and I understand that Terraform might not be the most accessible way for a newcomer into AWS and cloud and DevOps in general to understand concepts in a cloud provider. So I was thinking of doing the same demonstration but with AWS Web Console, and I was going to drop this video sooner, but in the middle of the week work decided to drop a real doozy on my desk. So here we are on a Saturday afternoon. Happy Friday everyone. If you know, you know. But let's get into it. Right, like the last time, let me just zoom in a little bit here. Right, so like the last time, I have the two accounts, workload A and a separate backup account. By the way, all the concepts that I'm going to demonstrate here, I've spent some time in the last video going into some depth. So if you don't understand what I'm talking about here in this demonstration, please take some time to go back to the previous video. I'll link it in here somewhere. So that video goes into what AWS Backup is and how it is kind of special in the rest of the AWS services. But in this one, I'll just do the demonstration with AWS Console. Right, so in the workload A account, which is supposed to be this account that has production workloads, I have a DynamoDB table and an RDS instance. So I've already created those accounts. Let me just go into that. So if I go to DynamoDB and RDS, I can show you there's a table called tracking, which is nothing special. It's just a placeholder table that I can use for this demonstration. So if I go to RDS and DB instances, there's a DB instance called mydb, and again this is just a placeholder resource. But what's more important here is the encryption configuration that I've used for these two resources. So if I go to customer managed keys and I select the key called critical data, now this KMS key is the one that I use to encrypt data in both the DynamoDB table and the RDS instance. Now if your architecture is simple, you can use a single key to encrypt resources that are classified as critical or more sensitive. You can divide your KMS key usage along the lines of the data classification system you have. But if your architecture is more complex, if it is spread out, it might be better to use separate KMS keys, because you have to maintain the KMS key policy. And if you use the same key for a variety of resources that get accessed through variety of principles, you might end up with a really complex KMS key policy. So in this case, I'll just show the key policy. If I switch to JSON view, and so I made this, I created this key using the web console. So by default it gives the account the root principal of the account admin access, and also I selected the AWS SSO or AWS IAM Identity Center role in this account as an admin too, so it gives that role all of these actions as permissions. So other than these two statements, I don't have anything in this key policy. So that's it. So going back to the demo, the first thing I need to do is to create an AWS Backup vault, but before that I need to create a KMS key that will encrypt the backup vault data. Now I have already created a key here. I just enable it. So I already have the key here, and if I also show the key policy, it's basically another KMS key that I created through the web console, and like the last time, it just gives the account principal and the SSO role, admin permissions into this key. That's it. So let me just go into AWS Backup, vaults, and create a new vault. So I'll just name this vault prod, standing for production data, and I'll choose the KMS key backup vault source as the encryption key. And I'll just I'll enter a tag just for my tracking purposes, and I'll just create a key. Now that's all you have to do when you create a backup vault. That's just an entry where you store your backed up data. Right, now that we have a vault, it's time for us to create a backup plan. Now if you go back to the previous video, you might remember that I described AWS Backup Plans as a special construct that kind of stands in for a backup strategy. It doesn't directly have all the resources that should be backed up, rather you associate the resources into a backup plan. So you have this decoupling between the backup strategy, the backup plan, and the resources that should be associated with these strategies. So like I said last time, each resource can be part of multiple strategies, multiple backup plans. Now for this case, I'm just going to create one backup plan, and that will basically backup data from the associated resources using hourly jobs. So let's go into backup plans and let's create a new backup plan. I'll just build a new plan here. I call it critical. I'll just use the same tag that I used before, and then I'll add a backup rule. Now a backup plan can have multiple rules, but for simplicity I'll just use one rule here, and that rule is going to be daily, not a daily one, an hourly backup rule. And I'll use the backup vault that I created, prod, and the backup frequency will be hourly. And the backup window for the resources, I'll just use a window that is closest to me so that I don't have to spend a lot of time doing this demonstration, which is, I'll use right. So just note that when you use the API, you have to, when you specify a cron expression, you have to go with UTC, because cron expressions use the UTC time zone. But when you create a backup plan from the AWS Web Console, you have a lot more kind of like quality of life structure. So you can select a time window based on the time zone that you use. Right, so I'm just going to start within 1 hour because I don't want to spend a lot of time with this demo, and finish within 2 hours. Point in time recovery is another feature that AWS Backup has for supported resources. So you can see that it has support for RDS, S3, DynamoDB and all of that. But for this case, I'm not going to use point in time recovery because I just want to keep things simple. It's important to understand that point in time recovery has a maximum retention of 35 days. Other incremental backups on the other hand has more retention period if you want to use that. And I'm going to skip the lifecycle usage here too, but because you can move data into cold storage. For example, you can move backed up data into cold storage after a certain amount of days, but you have to keep the data in cold storage at least for 90 days of retention. So I'm not going to use that. I'm going to just put 30 days here, which I'll not probably use. At this stage, I'm going to skip the cross account copy function, and let's just test in account backup functionality first. I'll just add the same tag I used before. Right, so advanced backup settings are not relevant. I'm not using any Windows based resources, so I'll just create a plan here. Now, right, so when you create a plan from AWS Backup Web Console, you get the option to basically associate the resources here itself, but to drive the point home that backup plans and resource associations are separate, I'll just cancel this here and go back to the plan. Now we have a critical plan here, but we don't have any resources assigned to it. So what we need to do is to go into the plan, scroll down and go into resource assignments, assign resources, and we get the same screen basically. So I'll just say every critical data, because unlike the last demonstration, I'm going to use the same resource association configuration to associate all the resources that I need into this backup plan. So the IAM role here is the IAM role that will be used by AWS Backup when it executes the job to take backups from these resources. So you can use the default role, but in the last demonstration, in the demonstration that I did with Terraform, I've created a custom role here. And I've used that role, but you don't really have to, because there's a default role that AWS Backup will use and create and use. So I don't really have to worry about that here. Now in the resource selection section, I'm going to choose specific resources. This is a really kind of interesting step when it comes to cost associations. Even in production accounts, you might not want to use all the resources in a backup plan, because the cost that will be associated with data storage will basically go out of your control. So it's probably better to include specific resources by either resource ID, or the best plan here might be to include resources with a tag selector. So I'm going to use specific resource types, and I'm going to select DynamoDB and RDS. I'm not going to include all the tables here. Now you can basically select the specific resources like I'm doing now, or you can refine selection. So you can basically select all the resources here, and you can refine the selection by a tag selector. So I'm not going to do that now, but when you use a tag selector, that basically ensures that you don't have to come back and edit this resource association every time a new resource is created. So this is a really good way to kind of create and forget your backup strategy. Well, not forget, but it is minimal operational overhead for you if your account has like a high amount of activity basically. Right, so I don't need to exclude any specific resources, so I'll just assign those here. Right, so we have our backup plan, basically a plan with a single rule that backs up data in an hourly schedule, and it has a resource assignment that assigns resources, specific resources that I have, the DynamoDB table and the RDS instance. Now remember that we used a custom KMS key for these two resources. For DynamoDB tables, it's not really an issue because DynamoDB supports what's called independent encryption. If you don't understand what that means, please go back to the last video that I did, because I kind of explained what these two encryption support modes were and how encryption happens with in-account and cross-account backup scenarios. But for RDS instances where independent encryption is not supported, I need to modify the KMS key policies so that AWS Backup will be able to encrypt and decrypt the data encrypted with that KMS key. So I'm just going to go into the KMS key that I used for encrypting data in those resources, and I'm going to switch to JSON view and I'm going to edit it. Right, so basically what I'm going to do is to allow the AWS Backup job role, the default role that I mentioned earlier that gets created and used when AWS Backup runs backup jobs. I'm going to allow that role access to this key so that it can decrypt and encrypt data in those resources, so specifically in the RDS instance. So that's what this somewhat unformatted statement does. I'm going to save the changes, and then it's just a matter of waiting for AWS Backup to do its thing. So basically there are no jobs yet because I scheduled the jobs to start at 2 p.m. on my time zone. And let's come back when we have some jobs here that successfully backs up both the DynamoDB table data and the RDS instance data into this backup vault. So when we go into vault, into the vault that we created, we should see a list of recovery points as a result of executed jobs. Alright, so this is the status of the jobs after about 20 minutes. You can see that 2 jobs have been created for the 2 resources that I associated with the backup plan. And if we go into the vault that we created earlier that was used as the destination, you can see that we have 2 recovery points for each of the resources. Now if there's another hourly job that is run, there'll be 2 more additional recovery points corresponding to those 2 resources. Right, so now that I've demonstrated how in-account backup works with AWS Backup, let me also demonstrate how to do a cross-account backup with the separate account that I showed you earlier. So the first step there is to create a backup vault in that central backup account. So going back to the SSO screen, let me just go into the backup account, the separate backup account. And before I can create a vault, I need to make sure that I have a KMS key to encrypt data in that vault. So just to double check that I have a key, it's called Backup Vault Central, and it's enabled, and I'll just show the key policy. It's nothing fancy, it's another key that I created from the AWS Web Console. So with that key in place, I'm just going to go into AWS Backup, and like the last time, I'm going to create a backup vault. So this one I'll just call Central and create and use the KMS key that I have in this account, which is called Backup Vault Central. Just add the same tag that I had earlier. Right, so we have a backup vault. Now, before I can use this vault as a central cross-account vault from other accounts in the same organization, I have to allow other accounts to copy snapshots into this vault. So that's done by using what's called a backup vault policy. So to do that, I'm just going to go into access policy here and click on add permissions. Now from the last demo, if you go into the Terraform code, you can see the same permissions that I'm adding into the vault. It's just I don't have the same kind of drop down option when I use AWS through the API. So for this case, I'm just going to allow every other account in the same organization to copy snapshots into this vault. So allow access from the current organization, and AWS Web Console is graceful enough to give me the correct policy, and I'm just going to save that policy. So we have a central vault, and we have modified the access policy so that other accounts in the same organization can copy snapshots into this vault. So I'm just going to copy 2 things from here, the vault ARN. Let me just get that, and also I'm going to need the AWS Backup Service linked role ARN from this account so that I can use that in the KMS policy when I need to copy snapshots from the source account into the destination account. Again, I described that scenario in depth in the last video. Please feel free to go back to it if you don't understand. I would admit a kind of complex scenario when it comes to encryption, especially in the cross-account backup case. So I'm just going to go into IAM and copy the ARN role for the service linked role for backup in this account. So I can see that that role has been created. So I'm going to copy that ARN into the nodes I have. Right, so I have those 2 pieces of information copied into a text file. Right, so we've created a vault. We've copied we've modified the vault access policy, and we've copied necessary information. So I'm going to go back into the workload account, and I'm going to modify the backup plan so that it also copies the snapshots across accounts. Let me go into the workload account. And in the workload account, I'm going to go into AWS Backup and into the backup plan that I created earlier. And this time I'm going to modify the plan, well, actually modify the rule, so that it will also copy the backup snapshots that it creates into the cross-account vault. So let's just modify this rule, scroll down, and I'm just going to select the same region, and here you can select a different region as well. There's no limitation, but for my demonstration I'm just going to use the same region, and I'm just going to check copy to another account's vault, because I need to be able to specify the vault directly by using the ARN. And I'm going to copy the vault ARN value that I copied earlier. Well, here AWS tries to be a little bit helpful, and it modifies your in-account vault policy as well, because when you copy into a cross-account vault, you can't directly restore from a recovery point that is in a cross-account vault. You have to copy the snapshot from the external account into your account vault and then use the recovery function from there. So to do that, you need to also modify the vault in-account vault policy, so that the cross-account vault is also able to copy snapshots into your account. So if you just click this allow button, you don't have to do anything, and it just basically adds this policy, this vault policy, into your in-account vault. So I'll just click allow, and backup recovery has been enabled. So if you go into the Terraform code that I shared in the previous video, you can see this policy in the code as well. So I'm not going to change the lifecycle settings for the cross-account backup snapshot, and I can also add another copy, which could be a different vault in a different region, but for this demonstration I don't need to do that. And I'm just going to save the plan, and just to show that our action modified the vault policy, if we go into the vault, we can see that the access policy has been modified so that the backup vault the backup account principal is able to perform copy into backup vault for this vault resource. Now we have enabled the vaults to interact with each other, but we also have to modify the KMS key policy so that AWS Backup in the other account, the central account, is also able to use the KMS key to decrypt the data before it can copy the snapshots across the account. Right, so to do that, I'm going to go into KMS, to the critical data key that I have, and I'm going to modify this policy and add another statement so that this time the AWS Backup service linked role in the central backup account is able to decrypt data using this key, so that it's able to copy that decrypted data across and then re-encrypt with a separate encryption key that it has attached to the central backup vault. Now again, it's a little bit hard to explain just in words. I have gone into depth in the last video, so use the last video as a supplementary resource for this demonstration. So I'm going to copy the statement, so if I try to break down this statement, it basically allows the service linked role for AWS Backup from the central backup account to decrypt data so that it's able to copy that data across the accounts. I'm going to save the changes. Alright, okay, JSON always trips me up. Right, okay, so now that I've modified the KMS key policy, I just have to again wait for backups to go through. So this time I'm going to keep an eye on the central backup account vault and see if recovery points show up there. Alright, so it has been about 1 hour since I last modified the backup plan, and 2 additional backup jobs have been created and completed. Now those have been for the DynamoDB table and the RDS instance. They completed within about 20 minutes of creation. But what's more interesting is if I go to the copy jobs tab here in the workload account, that 2 additional copy jobs have been created for the backup snapshots that were created from those 2 jobs. Now these took some time. I've personally seen that the variation for the time taken for these copy jobs to happen, it sometimes can be, near instant, but sometimes it can take about another 20 minutes. But this has also been completed, and so if we go into the vault in the in account backup vault, we can see the recovery points that have been created. And if I go to the central backup account and into the vault that I created there, central vault, I can see here that the snapshots for the DynamoDB table and the RDS instance have been copied here. So what's more interesting here is that if I go into one of these recovery points, I can see that the encryption key here is the encryption key attached to the central account vault. So that's basically the demo that I did in the last video, but this time in the AWS Web Console. Like I said in the previous video, I'll try to follow this up with more explanations on other features such as restore testing and how to do restore testing, or how to actually restore data from cross-account vaults if a situation demands it. But for now, I think this video is long enough. Thank you so much for watching. I'll see you next week.